Maybe I can share my screen to go over some of the things we've been releasing for Argilla and this label the last couple of weeks. The thing I'm excited about is the custom field. I'm not sure if everyone has seen that, but within Argilla, one question that we caught a lot of times is the need to customize UI, because normally we have three defined ways of representing data in terms of images, chat, or basic text. And now what you can do is actually pass this custom HTML template, custom JavaScript to your dataset configuration within Argilla. And then based on that, you can tailor our UI to your needs. It really help with visualizing data the way you want it. We created, for example, a cool 3D demo to render 3D objects within Argilla. We can go quite far with this in terms of customization. But really cool to see what everyone is going to build. And before a custom field, you would end up with something like this compared to the representation above. So you have way more control in terms of visualizing that. And for this label, we recently released this 1.4.0 release with offline text generations. You can send a lot of synthetic data generations to, for example, an AI, and then come back later, like a couple of hours later. And then you actually have this like data set ready to go. Like a lot of bug fixes, some improved caching for like steps whenever you define your synthetic data pipelines, so you don't need to rerun individual parts of the pipeline. There's some like visualization methods, bug fixes, some new like tasks for prompting LLMs to actually scale. So that's pretty cool. And we also created this basic text classification task, which might come in handy whenever you do like a few shots classification with prompts as well. That's cool. So for anyone having joined, let's see if I can share my screen. The slide actually shared in the chat. So the drive I actually shared in the chat, and anyone can have access. Feel free to either ask questions within the chat or within the Q&A, or can raise your hand at the end. So the idea for today is actually going over two things: slides for a very general overview of SetFit if you're not familiar with it, and then going over to a notebook and actually show you how you can deploy Argilla for free on a research basis yourself. And then actually going over labeling records, configuring your initial data set, and then also fine-tuning one of these SetFit models where you can swap out, for example, your inefficient classifiers for these smaller, more efficient models that are really trained and tailored on a specific UI. Let's go over a general overview of SetFit. For SetFit, it's a few-shot classification package developed by Intel and in collaboration with Hugging Face, and consists of two phases. Initially, you actually fine-tune an embedding model to differentiate better between the labels you've defined whenever embedding data, for example, positive, negative. And then on top of that, you train a separate classifier that can distinguish between these embeddings for these labels. Instead of combining this entire training mechanism, you separate the embedding part and the classification part. So for example, if you have this kind of few shots data set, you can start generating these pairs or the contrastive pairs between positive and negative labels. And by the fact that you actually have these triplets, you can generate a lot of different pairs or subsets. Then you could say, take text 1 and text 2, and that one's positive, or text 1. And then those are similar and not contrastive, or text 1 and text 2, and then they would be contrastive. So you can scale up only a few samples of your data to a lot of samples in that sense. So it would really work with the few shot classification. The first part of the initial tuning of the embedding model results in this. Initially, you embed all of your sample data within the embedding space, and things overlap, and there's some ambiguity within the different labels. And due to the fact that you then fine tune the embedding model, your embeddings are more distinguished. And then the classification layer can classify all of your content. Then, there's some nice things about model sizes versus accuracies. So SetFit actually performs quite well out of the box. You know, the model sizes, at least within their initial paper, were way smaller. And nowadays, there's way more sentence embedding models that have improved a lot in terms of distillation and getting better results on benchmarks. A cool package to check out is FastFit. It's an effort by IBM to make a better version of SetFit, or an alternative. I haven't played around with it myself much, but supposedly it's training even quicker than SetFit, and you need like a similar amount of data. even though the inference time is slightly slower, it would in theory help you train quicker with a limited amount of data. And then semantic routers, and so a package that requires LLMs, that would be less efficient in that way. So let's go over to the bit. Within the drive, there's also this efficient application with SetFit notebook. And this notebook holds an overview of all of the code that we're going to use. The goal is to build a dataset for text classification with initially zero-shot suggestions, because you can actually use SetFit for providing zero-shot suggestions. And then later on, also doing this fine-tuning based on actual labeled data within Argilla. And what we'll be using is a PC component review dataset that we generated synthetically with this label, this package I mentioned for synthetic data generation. And we'll be using datasets, transformers, SetFit, and some Argilla components. So for the people that might not be fully aware, there is a labeling data annotation platform that actually allows for its dataset definitions by defining input fields, output fields, and actually adding a lot of these feature engineered cool goodies on top of your dataset definition, like a vector for doing vector search, like metadata for filtering through records and these kind of things. And then instead of doing the filtering one by one, which would be boring, you can actually do it way more efficiently, as we'll show now with, for example, these initial zero-shot suggestions, which you can then later on use for filtering. So Argilla can actually be deployed quite easily on the Hugging Face file. If you go to Hugging Face, you can actually go to spaces. Then you can create a new space, give it an arbitrary name, like Argilla Meetup, short description, license, and whatever. Then you can select Docker templates, then choose the Argilla template, and then also select the hardware to actually use. For now, we'll just be using free hardware, and we're not adding any efficient storage, which you might want if you don't want to lose your data after annotating. A demo will leave that. On top of that, you can actually define a username and a password, which allows you to log into the UI. But by default, you can actually use the Hugging Face OAuth integration to log into the UI, so we don't really need that. And then you click either public or private, and then create space. This will actually launch the Argilla Docker image, which is launching a fast API server to interact with a database in the UI, a UI, and also Elasticsearch database, which also allows us to do semantic search and these kind of things from within Argilla. So that's the cool labeling goodies that I just mentioned before. So this normally takes 2-3 minutes, but I actually deployed a Argilla version before. So whenever you go to this page, you will actually see Argilla. You get a general overview of the pip install, how to connect to Argilla, and even how to create your first dataset. So we can actually go back to the notebook now, and then we'll actually connect to Argilla, start defining our datasets and doing these kind of things. Are there any questions in between? And again, otherwise I'll continue. Okay, cool. Then whenever you want to set up your environment, you can install the latest version of Argilla, install this specific version of SetFit, and then import all of the required things. So for SetFit, it has the same interface as most of the Hugging Face packages in terms of trainers and models. Maybe you're familiar with, for example, the SetFit model or trainer. A slightly different thing is like the template dataset formatting functions, and we'll come back to that later. On top of that, we'll use some accuracy metric as well, which we'll be using to evaluate at the end. Normally, when initializing to Argilla, you get your API URL and API key. But a cool new feature that someone contributed recently was that it can actually pick up these environment variables or these collab secrets directly out of the box. So you don't need to copy paste them every time that you're working with your Argilla environment. So whenever you've configured and you actually found those within the UI, as shown before, you can directly get started. On top of that, I also added a Hugging Face token to be able to load and download datasets from the hub whenever needed. So we'll be initializing and connecting to our Argilla, and then look at the data. What kind of features do we have there? Does the dataset make sense? There's this cool way to embed Hugging Face datasets within notebooks or whatever other place you might want them. And that's an iframe that you can use wherever you want. I always use it within notebooks because you can scroll to everything, you can select and filter as well. So you get a kind of overview of your data set. And what we'll be doing for this data set is looking at this text column. There's these text columns with reviews about certain PC configurations that someone got. The idea is that we will review the text column and assign positive, negative, neutral labels. You can also use SetFit or this enabled dataset generator for any other label. But for now, we'll be using this dataset. So whenever working with Argilla, what we do is always think about like the data set beforehand, understand what we want to achieve and capture these nuances within settings. We use the Argilla settings class to pass guidelines, and these guidelines will actually show up within the Argilla UI. We'll be adding input fields. So in this case, it's going to be a text field. And then output questions. So the questions are the questions that you expect someone to respond to, like one of your annotators, maybe yourself. And that's the label that the review should get assigned: positive, negative, or neutral. Then whenever you have defined these settings, you can pass them to a dataset class along with a name. And this will actually ensure that the dataset is created within your connected Argilla instance. We actually took these settings outside of the dataset so you can easily copy, paste, alter them slightly, and then recreate a dataset with the same settings, but then within like another name or another workspace, if you want some workspace separation for different users or teams within your organization. And that's quite useful to not have to completely redefine everything from scratch. So what you can see here is the dataset ID. You can see that the dataset has the status ready. On top of that, there's an automatic distribution of each one of the records to allow for at most getting one response. So you can set this distribution to 2 if you want your annotators to have 2 responses per record or per data entry. That might be good to see if all of your annotators align, and whenever it wouldn't align, you could review those records specifically. So when we go to the Argilla UI, you can see that this data has showed up here. And you can see that there's no record yet. And there's apparently some documentation and guidelines here that you might be able to use. As of now, there's no progress because there's no records. And you can actually see like an overview of the questions. Let's say that you want to customize like the configuration. There's some things that you can actually configure from the UI and some things that you can configure from the SDK side. So in this case, you can, for example, set the fields as like using Markdown, or whenever you might want to render your HTML in Markdown. There's some questions that you can alter. So for example, if you want your annotators to have a little bit more nuance, you can add a description like positive equals very positive. You can order the labels. Apparently neutral might be better fit here in between to avoid bias. And you can, of course, delete your data set. So whenever you go back to your data set, you can also see that like this has been updated. There's a description here: positive equals very positive. By really thinking about your UI and your dataset configuration, that all of the annotations goes as smoothly as possible, and that everyone is on the same page about what the annotation task is going to be about. Then we can actually obtain that dataset from the Hugging Face hub by referencing the name here, and we will be able to get like the dataset back as well. So what we'll be doing now is we'll be adding records from this PC component review dataset. There's 100 records available, but we'll be using the first 51 to train, evaluate, test the setup. And then at the end, we'll use the remainder to actually go for an accuracy test against the improved model. So in this case, we'll be logging the records from the dataset. And what we'll be doing is actually adding this mapping. So as you might have seen, we defined this text field with the name review. And within the dataset, there's this text field called text. So you have the option to play around with this mapping to allow for mapping arbitrary columns to your dataset settings. In this case, we'll be adding some records to the overview. And we can see that 50 records has been logged, that there's some update here, like last updated status, instructed status. And when we go back to the UI, refresh, then the record should have shown up here. And you can actually see like some of this logic there. So what we can do now is use SetFit to work with this zero-shot classification functionality. Based on the candidate labels, we'll create a data set to overfit your embedding model. We're creating a data set with a lot of fake samples. These fake samples are formatted in like this sentence label. As you can see, this sentence is positive. And apparently that's like a way in which you can force these embeddings, what the picture I showed in the beginning, to be more distinguished, like these specific labels, either positive, negative, or neutral. And there's some ways to override this specific template, but for now we'll use the most out-of-the-box settings because there's a lot to optimize within this entire pipeline, but we'll keep it simple for now. Based on your initial data set with labels and text, you can then fine-tune this initial model. So within the SetFit fine-tuner, the two steps of initially fine-tuning this sentence embedding models to create their embeddings, and then also training this separate classification head, normally based on a sklearn classifier, is done within one overview. In this case, we've defined this function to train a model, but it's not always clear which model is the right model to use. And in case of sentence transformers or learning models, there's this cool benchmark, the massive text embedding benchmark. And this contains an overview of all of the models submitted to this leaderboard. Within this leaderboard, you can actually filter based on characteristics. So, for example, what we can do is we want to have a very small model to optimize for speed and then efficiency. We don't want to use any GPUs or whatever. What you might do here is select certain model sizes. Based on these model sizes, what we can do is go for example, classification model. And then what we can do is filter on the model size even further. Based on this, we can look at the average scores. This one scored good, like the BGE micro. So you can go to the hub and hop into this model. You can also see what kind of scores they had on different benchmarks. For example, the review classification benchmark for Amazon might be relevant. It's good to keep in mind that these leaderboards and benchmarks try to capture some of the ones in the real world, but it's never going to be able to capture everything. So it's always worth looking into what data sets it scores well on and what it doesn't. And then eventually what might want to fine tune a model and need something tailored to your own domain and company. And then going back to the notebook, we'll be using the Taylor AI model because it's small and scores high. We can train this model to overfit on this synthetic mock dataset. This will run on a Google Colab, no GPU, just CPU quite quickly. The sentences are very short, but it's efficient. And then after not even a minute, the model has been trained for zero-shot classification for these specific labels. We can then save or load the model to the hub. Whenever you do that, so here, you can actually create this model repository. In this case, I can say David Bernstein, 7 text classification model, and then say 0-shot, and then choose the model tab. Of course, it doesn't work. I think I have the working token, you know what, Bernstein. And then it will create this model in the hub. Only 70 MBs, and you already have your initial fine-tuned private model. You can also save it to disk if you don't want to save it on the hub, and that's already pretty cool. So what you can do with this model now is do these predictions to test if it works, and do this zero-shot model. This was a very bad experience, apparently negative. This was a very good experience, and let's see if that's positive. So the model has apparently learned something, and is actually able to predict some basic initial suggestions. And based on that, what we will be doing is looping through each one of the Argilla records. Then for each one of the Argilla records, we're calling this predicts function with the zero-shot model. and then the review field. So the text that's originally within the dataset. And on top of that, we'll be passing the labels as well. This suggestion is then formatted according to Argilla, what we expect within an Argilla dataset, and we'll link it to the specific question name. So this corresponds to the question that we have defined within the input settings at the beginning. After that, we'll be like updating the records. So we'll have this updated record list. We will append the records, and then we log the records to Argilla. The thing is that whenever you use records directly, there's actually an ID attached to each one of the records after initialization. Whenever you have this ID available, the record is updated based on that ID and not completely overwritten or recreated. So this doesn't take long because it's a small and efficient model. And whenever we go within the UI now, and we refresh, we can actually see that there's some like labels attached to the overview. And that's already cool because apparently this model has been able to predict some of these labels. What we can do now is go for efficient features that we have in terms of filtering and sorting. So what we would be able to do is apply a filter where the suggestion for sentiment label has a certain label. In this case, we just want to label some positive examples to actually verify if it's okay to look at the data, understand whether the data makes sense. Maybe something isn't captured correctly. Maybe some things need to be updated in the pipeline producing the data. In this case, we filtered on positive. So what we can do now is select the first 10 records that have this match of being positive, and then we can go through them. So in this case, impressive, power consumption is higher. It's good to use some tweaking to keep temperature in check. So maybe that's not really positive. It's neutral. Like some things are positive, some things aren't. Gaming keeps temp low, noise levels. This is actually positive. And then you can go through these records one by one. You scroll to the next record whenever it makes sense. And then whenever you have enough examples, in case of SetFit for a basic simple classification task, you only would require 10 labeled records per example. So in this case, we'll find the label, say submit, and then we see that, for example, the status here is updated. So there's only 41 pending records left, as me as an annotator has completed some of the records. And what we see as well is that like all of these labels have been set to positive. So for SetFit, as mentioned, you only need 10 or 8 examples for these kind of classification tasks. So what we can do now is actually move away from the positive label and do a neutral label. Once again, you can open your dataset, start by selecting every one of them. Solid choice, but not without occasional hiccups. That kind of sounds neutral or mixed. Similar here, managed to get everything set up without any major usage. It was a bit tricky, so I guess also neutral. Then you would go once again through each one of these examples one by one, and then label neutral. Besides these basic filters for suggestion labels, you can also pass a score to each one of your predictions. Whenever you have the log procs available, you can use those for certainty. You can add custom metadata as well to allow for more effective filtering. If you have a certain date you want to filter by, or certain subcategories within your organization, you can attach records to each one of your vectors. That might be useful to improve the labeling. So now we have labeled the positive examples, the neutral examples. So we can actually continue to the last set of labels, which are the negative examples. In this case, we'll assume that everything is use case. We select 10 records, label them as negative. Normally you would go through and ensure that your data set is of the highest quality, but for the sake of the example, we'll continue. We've done some evaluation in Argilla. We've done this labeling setup. We know that we have a very good high quality data set. We can now fine tune and model on top of like this actual data. So for Argilla, once again, you can now get the data set to be sure. What you can do is actually apply this complex filters within Argilla. So in this case, we'll filter on the response status being submitted. You can also do vector search. You can search based on suggestion scores. There's a lot of syntax there. And within this how-to guide, you can find how to do that yourself. Based on that, we have this submitted status filter. With that status filter, we will get the records. So in this case, we'll get the records. There's been 27 that have been submitted. But we Can also do is, for the sake of the example, look at the first records where you can see this ID that I mentioned before that you can use to override certain records within your dataset. You'll see the review. You'll see the sentiment label responses, my user ID, the status, some suggestion label, and then the suggestion score and agent, which we left out for this case. But whenever you have different models to compare or want to filter on uncertainty scores, you might be able to add that as well when refining your suggestions. For the SetFit, you need 8 examples per label. What we'll do is actually create this sample data set, but then from a list of actual data. So in this case, we'll get the review from the record and we'll get like this sentiment label response, which is like the positive one. As you might notice, this is in a list, and that's due to the fact that at times there might be multiple users responding to the same record. So you would be able to resolve the alignment or an alignment of each one of your annotators. Then you have your train data set. We can also look at the first example. And this overview, we have your text. And then for the train data set, we can actually use this to fine tune our model. This is going to be like the few shot model with the actually couple of examples. So not the fake synthetic zero shot examples. And we'll like fine tune this model train data sets. If data set equals train data sets. What we do here is we actually have some labeled examples. You have our, like, once again, the same model by default. In this case, it will take a little bit longer to train, but still it's going to be fairly efficient and quick. Once again, just using CPU now. So whenever you have available or the GPU from a non-Mac, it could be a lot quicker to actually fine tune. Also, you can upload your model, push it to the hub, and make sure to update the name so that you don't override your previous model. But also, if you override your previous model, there's always these git commits messages for each model version that you upload. So you can actually revert back to one of the previous versions. This model is almost done training. And it's pretty cool because it's really quick to go from a demo to actually fine tune a relevant, more efficient model for this use case. Then for records, the remainder of the records, what we can do is actually get a better model and update these suggestions. So for the example, what we can do is say better as a added agent tag that we mentioned here before. And we can even say due to the fact that it's a better model, the score of the suggestion is quite likely going to be higher. Could also get directly from your model. So in this case, we updated the 50 examples. If that's okay, then we are supposed to get better prediction scores for suggestions. And after, finally, we can start evaluating. We only picked the 50 first examples. And here, what we're doing is getting everything after the 50th example, which gives us a data set of 50 in this case. We'll load the data set, predict methods once again, but with the few shots model. We'll use the text column of the original data set and the set of labels that we might want to apply. Then we can evaluate these predictions against the original data sets. And then whenever you have your labeled examples and you have actually reviewed your data, the prediction score should be higher than the officially assigned labels. In this case, due to the fact that we didn't spend that much time on curating and annotating examples, it's going to be less efficient. But normally, whenever you start labeling and actually improving your model, then you'll end up with a higher accuracy and normally also a lower model. So there's lower model charts. So there's different things that you can do, for example, for these zero-shot suggestions. In the case of using an LLM or LangChain or DISI label to label, you can avoid being dependent on their APIs. You can use a smaller model that might even run on device in SetFit models to really go from this dependence of models and separate companies to having your own private model running on your laptop. That's a cool thing about some data curation and using these smaller models. I'm not sure if anyone has questions. feel free to have. I think Brandon not the we well you have this one this week. The audio is a bit lacking for me, but or do you kind of falter? I'll just put pausing. Okay. The, there have been some questions, a way to update suggestions programmatically via callback or listener than what we've done in the demo. So what we're working on now is actually this webhooks feature where you can set up like your webhook server that continuously listens to events within your Argilla like deployment. So you can, for example, choose to listen to record events whenever a record is done with annotations or whenever a data set is updated. And then when one of these events happens, this event is actually passed to your webhook server. And within your server, you can actually do like operations on them, define these background processes, and actually based on these events, do certain actions. So you could also do whenever your data set is completely done with annotation, send a ping to yourself in terms of getting a notification that your data set is done. You can actually start like fine tuning pipelines on top of that. For example, for SetFit, if the data set is done, you can just run SetFit like fine tuning on device. It take maybe a minute, then replace your previous model with that if you might want that. So there's some configuration there. And the other question seems to be a copy, for example. Yeah, okay, it's in the same place. Yeah, so for the SetFit fine tuning, you can use any model, but the sentence embedding models, they work best out of the box, like the sentence transformer models. And you can actually use this MTAP benchmark to fine tune, to find the correct model for your use case, your task. There's some things to consider within like this MTAP leaderboard. Also the size, for example, or like of dimensions or these kind of things. Whenever you work like longer documents, you might consider that too. So take review data, classify them, but also trying to classify keywords within a text to understand sentiment around specific keywords. I think for SetFit, there's this aspect-based sentiment analysis, and that's exactly the use case. So whenever you would work with potentially classifying text, but also wanting to see whether specific segments or specific spans within the text correspond to a certain sentiment, then you might be able to use this like integration of, and that's the aspect-based sentiment analysis. I can maybe share my screen to show you. So this is like the integration for that. And maybe they have a nice visualization. So what you can see here, model predicts best pizza outside of Italy and really tasty. And then apparently for pizza or the specific word pizza, there's this positive polarity for the food variation, positive, and then for weighting number and negative, because apparently there were people complaining about that. Is there a limitation regarding the texting, classifying transcript voice conversations with a customer? Yes, this is possible. So whenever you would go into this MTAP leaderboard that I mentioned, you can see length, I think, that the models are able to handle as well. Not sure if it's not loading now. But yeah, you should be able to see these kind of things. So you can actually see the max tokens. So whenever you would want to work with a model that's larger in terms of the maximum number of amounts of tokens that it can process, you can filter on that. So in this case, apply a filter, and thing that you need to consider is then that the model might be larger, slower, but also maybe performing better, but also quite likely going to be more difficult to fine tune to a specific use case. It's kind of trade-offs there. Still, like whenever you choose like a small model, you will be able to fine tune. But as you can see here, for example, the model size for these larger models is larger in this case compared to the model size that we had initially, the example. So basically for a sequence, yeah, you will need them. Yeah, to come back to the question, SetFit is for sequence classification, text classification, and any model can be used. And on top of that, there's also this aspect-based sentiment analysis, which is pretty cool. You can classify spans that are corresponding to either positive or negative within a specific sentence. So that's also a useful feature especially whenever you deal with reviews. I can imagine that maybe like this pizza company wants to get an overview of things that are good and bad in their company. And then you would be able to extract these specific keywords corresponding to positivity or negativity as well. But basically, any of the models from the MTAP overview can be used within SetFit, but you can also use other transformer models. Not sure which one of them have all been integrated, but out of scope, we use guide review. So I'm not sure if there are any more questions. Did you try to fine tune embeddings and use them embeddings for reg stuff? So I think you would be able to do that in terms of fine-tuning an embedding model using SetFit and then using that for a RAG system. But you need to be aware of the fact that when fine-tuning such an embedding model, you actually fine-tune based on overfitting the distinguishments between each one of these labels. So if you have a RAG system that you would work with in this specific scenario where you want to distinguish like different groups of documents, it might be a fetch, a stretch, but yeah, you also do need to keep in mind that you do lose some some of the semantic representation that these embeddings normally have. When train embedding models for a specific language, when a paired data set is not available, what you might be able to do is there's these multilingual or cross-lingual capabilities for models. So what you might be able to do when you want to fine-tune a model on a data set that's not the original language that you intend to use your model on, is just use a cross-lingual model or a model that performs well on cross-lingual benchmarks. And then based on that, you can do like your fine-tuning and classification later on. And for fine-tuning a V-ranker model, as Ben mentioned, somewhere it's better to use sentence transformer models in that case. So you can just use the direct library for that instead of using something like this. Can I use SetFit? So yeah, SetFit, I believe that the license for SetFit is open source. For each one of the models, you actually need to check. Along with this, you can actually see the model types. So in this case, there's within the leaderboard, you can see some models that are like proprietary and that you can't use. So in this case, there's none, probably. Maybe the filter doesn't work. But whenever you see like a model that you're interested in, so let's say the Gina embedding model, you can often within the hub actually see the license. So here, this is an Apache license, so you can use it out of the box. But whenever like there's one of the other licenses, it's always good to see, can actually use it. Some models have a restrictive license, so you can actually use it up until certain revenue within your company or a certain scale, or you can use it for fine tuning if you actually reference that what the original model was all about. And yeah, kind of give some new ones there. That sentence transformer is better. Yeah, sentence transformers are like the original sentence transformer library is better for fine tuning embedding models than the SetFit implementation. So SetFit uses sentence transformers under the hood, but this is like the original library for fine-tuning sentence transformer models. QA, force looking to train re-ranker model. So that should be, yeah, but I think for training a re-ranker model, it's better to use this original sentence transformer library. A cool thing that we included in this C-label a while back is actually this guides for generating synthetic data for fine-tuning embedding models. So this might help for your use case. So I will just leave it here. For classifying and annotating words to understand sentiment. Yeah, so for this aspect-based sentiment analysis, and that I showed before, you can actually like load this information into Argilla with a Sven collection. So we have this dev environment that I can maybe briefly show you. Let's go in there. And within Argilla, there's a lot of different overviews. So in this case, what we can do as well is have, for example, this toxicity thing, if it's toxic, yes or no. And then on top of that, also highlights like the certain parts that are positive or are toxic or aren't toxic. And then you can combine this aspect-based sentiment analysis within one overview. You can even add like multiple text fields on the left-hand side or more questions on the right-hand side. For example, You might be adding a text question that allows an annotator to provide nuance as to why it chose for the toxicity rating, even more than just like selecting the spans. Oh, finally shared a tutorial there. So this is like a tutorial about the C-label and synthetic data generation for sentence similarity data or re-anchor data. So if you don't have a data set dedicated to your domain, apparently what works well is using one of these larger LLMs to generate data sets that are representative for your use case. You might be able to add some seed data to your prompt, and then based on the seed data, ask or prompt the LLM to rewrite. Does Argilla listeners still exist in Argilla tool? Argilla listeners, as we knew them, don't exist at the moment, but we are actually working on creating this new Argilla listeners within our webhook integration. So then instead of listening to these query events, you listen to webhook events, and these kind of are roughly the same as we're familiar with. So whenever it gets updated, whenever a record gets created, whenever a record gets deleted, you can actually capture these events with webhook listeners. And based on these captured events, you can then call Python functions. So that's the new iteration on these listeners. And I believe that the ETA for these listeners is going to be the next release. So that's going to be like in a couple of weeks. But make sure to start a GitHub repo or watch it, and you'll be updated on each one of the releases. We can send them many new features.
I think it's next week.
Yeah, it's next week. Okay, perfect. Thanks for the nuance, man. Cool. Are there any more questions? Or anything someone might want to show or discuss or talk about? It's also cool to see some use cases of the community if anyone has one, or questions about some other projects that you've been working on, like text classification, SetFit related. Thanks for the kind remarks. Mixture of expert questions. I'm not an expert, so to say, but I will try to answer it, and Ben is available to help as well. Hello.
Thanks.
Put in. Yeah. Oh, your audio is a bit flaky. If you want, you can also post it within the chat.
I would
There's an echo in my mic. Letting me know.
Yeah, no. Is it echoing? Hello, am I audible? Yeah, sure. So my project is I'm trying to fine-tune LLM for multiple languages, intake languages. So we have 7-6 languages, but we have to scale that. For example, we can't train each LLM for each language. So it would be very, for production use case, it would be very cumbersome. So I have to train a LLM, have experts for each language. And when a user type a specific language, it should fix that trick expert that I have trained using that LLM. So how to do that, or how can we proceed? How with a mixture of experts a good option, or do you have any other suggestions?
Think it might be worth like starting to look at like which LLM is most well performing for like on pre-training for like indie languages. And then what you can do if you want to train like LLMs for specific use cases is also this LoRa adapters. So instead of fine tuning the entire LLM, you would then be able to add some layers on top of the LLM and just fine tune those. So it's, I think, easier to experiment, easier to see if there's some results to be had. Because also for LLMs, which you often see that compared to all of these pre-trained LLMs that perform very well on English, there's some difficulties to make them work for specific languages. And I think LoRa adapters are easier to iterate, and they've also proven to work. But I'm not sure, maybe Ben has some more nuance.
No, that sounds like a good place to start. And I would also, as everything, just start with a good representative data set of the problem. and that lends itself to whether it's a lower or another fine tuning method. And then probably go to SSD, and then after that.
And there's, whenever you're lacking in data, apparently you can generate this data synthetically. So normally what you do, what we also did with this SetFit example, start with a smaller, with a bigger model, then work towards a smaller, more fishy model. And it goes the same way for LLMs. So whenever you use an LLM for text classification, you can start it, for example, with a SetFit model. When you want to use an LLM for these specific generation use cases, you can choose to initially start off with a very large LLM, use that to generate synthetic data, and then based on those generations, fine tune a smaller, more efficient LLM for your specific use case. Because especially when you use these larger models, they often perform better on benchmarks, but also real life scenarios. So they also perform better in terms of generating representative synthetic data. In a hackathon where two candidates are to be scored based on a transcript and a resume. Transcript A, transcript B, transcript, let's say, for a given role/communications, we have to give candidate A and B and select one. What's the best way to solve the problem? I'm not entirely sure. It's also difficult to say in terms of ethics about making model predictions on resumes, but maybe that's like a European point of view. But what you would be able to do, for example, what we always think of whenever you work for, like an example for a client use case, sit down with them. What do they find relevant within a resume? Maybe there's some certain aspects within their job history for which you would be able to train a classifier. Maybe a certain aspects within their educational history. And based on that, what you might be able to do is do this, initially train some basic classifiers. And then within a UI or an overview, have these initial model predictions already available, or have some LLM generate some new ones if you want to use LLMs. And then one by one, I would say go over within a UI of some sort to really review each one of these applications individually. Because LLMs are nice and they can do a lot of things, but also what we've seen after a year of usage is that still at times they can be flaky, hallucinate, do weird things that aren't really aligned with what you expect. I think to overcome that is, of course, getting some few shot examples, but also this doesn't always necessarily work. So I think initially start off with some models, split up the problem wherever possible. And then from there, go to also looking at your data, looking where the model performs well. Maybe it performs very well to see if an educational history makes sense for the role, but maybe less with the work history. So you can divide and conquer the problem there. Any more questions? Cool. You're welcome. The explanation. And if there are no questions anymore, then I would like to thank you for coming by. It was like a super cool session. We hope to be doing more of these sessions, either about some basic RAG scenarios, NER scenarios. If you have cool ideas that you would like to hear us kind of give a session about, feel free to reach out either on a lead base, within one of the GitHub repos or these kind of things. The recording for this session will actually be shared after, also on socials and within the Discord. So feel free to connect. Could I get an email or social media? So for me, it's David Bernstein. For Ben, it's Ben Burton-Shaw. So whenever you want to connect on LinkedIn, you can probably find us. I hope to see you in a couple of weeks again. Bye-bye. Thanks for joining, and see you later. Hey.